Hello everyone. I am here to present Embedded System Internship project of Washing Machine Simulation and Internship Guidance of Emerging Information Technologies. This project is presented by me, Puja Kumari, currently studying Electronics and Communication Engineering at PIT Sindri. So let's start. Washing machine has become integral part of human being. It is a household appliances used to wash clothes and other fabric items over the course of time. Washing machine has evolved. This has happened due to rapid advancement in embedded technology. In this we will try to understand how we can model our own washing machine and what are the difficulty we are going to face and how we have solved them. So in this internship, we mainly learned two important parts. First is embedded C programming like keywords, number system, data type modifiers and qualifiers, conditional constructs, operators, array, structure, function, pointers. And second one is about microcontroller used PIC microcontroller, especially PIC 16F877A. So here we use software like MPLAB XID compiler and hardware like LCD, LED, keypad, motor, timer and microcontroller. Now let's move to embedded C programming, in which number system is used to represent number in digital computer. Data types define the type of data that variable can store. Data types can be char, int, float, double. Data type modifiers and qualifiers are keywords used to alter the properties of data types. Conditional constructs can be of single iteration and includes if and switch case. Multi-iteration types, it includes for loop, while loop and do while loop. Next, operators are the symbol used to perform operations like arithmetic operators, relational operators, logical operators. Array are the data structure that can be stored multiple values of same data types in contiguous memory location. Functions are the block of reusable code that performs a specific task. Pointers are variable that store memory addresses. Now, let's proceed with embedded system. Embedded system is a combination of hardware and software which is intended to do some specific task. Now let's looking for some few examples of embedded system. As you can see in this image, we have micro oven, washing machine, TV, cameras, robotics, medical appliances, etc. Similarly, for washing machine, this is done the work of washing, so each of them are dedicated to do it on some specific task. Then we call this as embedded system. Now let's looking for basic structure of embedded system. So this is the block diagram of embedded system, and we can see microcontroller is the main part of embedded system that connects the majority of component present on the part of computer system. SoC stands for system on chip. This is the integrated circuit that connects to the majority of component present on the computer. Embedded system requires memory to store program instruction, data and variables. There are two type of memory. These are read-only memory and random access memory. Input devices along the embedded system to interact with its environment by receiving input signals. For example of input signals are sensors, switches, button, keyboard and touch screen. Similarly, output devices allow the invalid statement system to communicate with users or other system by producing output signals include display, speakers, equators, and LEDs. There are various communication interfaces in embedded system. These are serial interfaces, Wi-Fi, Bluetooth, USB, and etc. Embedded system required for stable power source to operate. Real-time clock provides a reliable source of time information even when the system is powered off. These components work together to enable system to perform their intended function, reliability, and efficiency. So, requirements of washing machines are hardware like LCD, LED, keypad, motor, timing, and microcontroller. Software like MPLAB, XID, compiler, and PiximLab. This product is based on PIC16F877A microcontroller. So, microcontroller is a device that has own inbuilt memory and processor. PIC is such a microcontroller. The full form of PIC is Peripheral Interface Controller, which is developed by microchip technology. So because it is a very easy to use, PIC16F877A is prominently being used to beginner and professional. Keypad, this is where the user give input to turn on or off any particular device into microcontroller. They can be triggered into different ways. That's your level record or strict level triggered is activated when voltage is in one high level STD is activated. When level of voltage is suddenly changed from one level to another level. So they come into different configurations. One is sourcing for the circuit and another is syncing for the circuit. Sourcing is one is considered to be on and 0 is considered to be off. And in syncing circuit, 1 is considered to be off and 0 is considered to be on. Just opposite, so the diagram syncing circuit. Now CLCD. CLCD is a dot matrix liquid crystal display. As you can see on the right of the screen, it can be operated in 8-bit mode and 4-bit mode. So timers. Timers is nothing but a simple binary counter that can be configured to count clock, pulses, internal and external. Once it reaches to the max value, it will roll back to 0, setting up an overflow flag and generates the interrupt if enabled. PIC16F877A has 3 independent timers which can be used to timer, counter or for PWM generation. They are timer 0 8-bit timer, timer 1 16-bit timer and timer 2 8-bit timer. Interrupts. An interrupt is a communication process which causes the processor to stop its current task and handle interrupting sources. Sources can be external, internal. PIC has only interrupt service routine. These are the software components that are required for the project. The first one is MPLAB XID. MPLAB XID is a pre-integrated toolset for the development of embedded applications on microchips PIC and DSPIC microcontrollers. It is called an integrated development environment. So this is the software we are going to write the code and execute it. Here, PiximLab. PiximLab is a real-time emulator of development boards with integrated MPLAB X AVR GDB debugger. PiximLab supports some Pixim microcontrollers and some SIM AVR microcontrollers. PiximLab have integration with MPLAB X Arduino IDE for programming the boards of microcontrollers. So this is a snapshot of hardware that we are going to use the microcontroller is PIC16F877A. The board is PIC Genius. Now let us go to project demo. There are 6 switches, which is switch 1, switch 2, switch 3, switch 4, switch 5 and switch 6, and a fan and a buzzer. Here you can see PICsim simulator is on. You can see on the screen it's showing press key 5 to power on washing machine. We will press key 5 on this washing machine. Key 5 is RB4. So I will press RB4 to start this. After pressing, you can see it's showing powering on washing machine. After that, washing programs is to be selected. So we have around 12 programs. We written like daily, heavy, delicates. To navigate between the programs for this demonstration, I choose daily washing mode. Now long press to RB3, which is switch 4. So let's wait for 20 seconds. Now it's have been selected. Okay. It's asking for water levels. For water levels, I have to select auto. Then we have to press and hold the button for 20 seconds. Okay. Now we are getting 2 options like press switch 5 for start and switch 6 for stop. Now we will press RB4, which is switch 5 to start. And if we use RB0 interrupt, which is basically open the door, the time taken by daily wash is 41 seconds to wash these clothes. Wash, rinse, and then spin. Okay. After the wash is completed, it will show on the screen the task is completed and please remove your clothes, and the buzzer will automatically on. In this way, we have completed our project. So this is the code which help for execution for the project. So here is source file. Source file includes main.c, timers.c, digital keypad.c, clcd.c and isr.c, and the rest of header files, which includes the file like clcd.h, digital keypad.h, main.h and timer.h. Now let's move to our conclusion side. So in conclusion, we can say washing programs has placed a very important role in modern society. So in this project, we are trying to model a washing machine by going to entire development cycle. We have understood the requirement of the customer and have tried to add own feature in order to improve to experience. So this is while implementing the divided each functions into modular program and try to combine the whole this multi-hole process of development easier, and we are able to detect any anomalies easily. So lastly, I will say thank you.